Hi guys, so today we're going to take a look at question 9 from paper 2 of the 2015 exam. Okay, so Joan is playing golf. She is 150 meters from the center of a circular green of diameter 30 meters. Okay, the diagram shows the range of directions in which Joan can hit the ball so that it could land on the green. Find alpha, the measure of the angle of this range of directions. Give your answer in degrees correct to 1 decimal place. Okay, so, well, what do we... Okay, so the information from the question is nicely captured by the diagram itself. Alright, so now let's try and see what we can figure out from the diagram. Well, if this is the line from where we are to the center of the green, we actually know the length of this. So we know that this is 150 meters. It's pretty clear to see from the diagram. And now we also can figure out what the length of this side is. Okay? Since this is the radius of the circle, this is just 30 over 2, 15 meters. Okay, and now what is it that we're trying to find? Well, we're trying to find alpha. And because we've drawn a line to the center of the green, this line, our blue line here, has bisected the angle alpha. It's bisected this angle. Okay, so let's call this angle beta. Okay, and so alpha equals 2 beta, or beta equals alpha over 2. Okay, so, well, if we could find beta, that would be very useful. And we notice that we have a right angle triangle where we have the length of two sides and we're trying to find an angle. Well, immediately we think of our trigonometric formulas. So we have sine, which is opposite over hypotenuse. We have cosine, which is adjacent over hypotenuse, and we have tan, which is opposite over adjacent. And the sides that we have are the opposite, which is this length here, this side here, and we have the hypotenuse, the side opposite the right angle. So we're going to use sine. So sine of beta is the opposite over the adjacent, 15 over 150. Okay, so now we can use our inverse sine inverse, to get beta. So sine inverse of 15 over 150 would give us beta equals 5.74 degrees. Okay, so we found beta, and now this will allow us to find alpha. Alpha equals 2 by 5.74, which equals 11.48. 48 degrees, or correct to 1 decimal place, 11.5 degrees equals alpha. Now this is a very nice question if you notice that the line from the center to where the ball is splits the angle in two. That's kind of the trick in this question to see. Now on to part B. At the next hole, Joan at T attempts to hit the ball in the direction of the hole H. Her shot is off target and the ball lands at A, a distance of 190 meters from T, where the angle ATH is 18 degrees. TH is 385 meters. Find the distance from A to H, the distance from the ball to the hole, correct to the nearest meter. Okay, so again, we're getting the information is getting covered nicely by the diagram, and we are trying to find this length here. Okay, so, well, what do we have? Let's just write down what we have. So we have a triangle. We have a triangle TAB. We have two sides, TA, which equals 190 meters. And we have TH, which is 385 meters. And now we also have the angle ATB equals 18 degrees. Okay, so, and we're looking for, what is it we're looking for? We're looking for AH. Okay, so we have a triangle. We don't know if it's a 90-degree triangle. Maybe it is. Probably doesn't look like it. And we want to find the length of one side given two sides and an angle. Well, what can we use for this? Well, we can use the cosine rule, which is c squared equals a squared plus b squared minus 2ab cos c, where c is the angle opposite side C. Okay, so in this case, C is what we're looking for, AH. A and B are the lengths of the other two sides. So let's say A equals AT and B equals HTH. And our angle is the angle opposite AH. So that's just 18 degrees. Okay, so now if we just plug this into a formula, we get that c squared, so AH squared is equal to a squared, so AT 190 squared plus TH 385 squared minus 2A 190 B 385 cosine C 18. And now if we solve this, we get that AH squared equals 45,185.43. Okay, so that's our distance squared. So if we square root this, we get AH equals 212.57 meters, or to the nearest meter, 213 meters. On to part C. At another hole where the ground is not level, Joan hits the ball from K as shown. Joan hits the ball from K and the ball lands at B. The height of the ball above the horizontal line is given by h equals minus 6t squared plus 22t plus 8, where t is the time in seconds after the ball is struck and h is the height of the ball. Okay, so we want to find the height of k above OB. Okay, the height of k above OB. Well, let's just write down our formula. The height equals minus 6t squared plus 22t plus 8. Okay, and t is the time in seconds. After the ball is struck. So before the ball is struck, so at t equals 0, before the ball is struck, the ball's at k. Okay, so let's try and use that to find what h is at k. So h equals minus 6 by 0 squared. So let's call that hk. Minus 6 by 0 squared plus 22 by 0 plus 8 equals 8. So k is 8 meters above OB. Now on to part 2. The horizontal speed of the ball over the straight distance OB is a constant 38 meters per second. Constant 38 meters per second. Find the angle of elevation of K from B correct to the nearest degree. Okay, so, well, let's just first identify what it is we're looking for. We're looking from the angle of elevation from B to K. So that's just this angle here. Let's call this theta. Okay. So, well, what do we know? Let's just write down what we know. The horizontal speed of the ball over the straight distance OB is a constant 38 meters per second. So let's just write a speed horizontally is 38 meters per second. Okay. We also know that K is 8 meters above B. Okay. And is there anything else we know? Well, we know that the height is modeled by this formula, minus 6t squared plus 22t plus 8. Okay, so we've written down what we know. We know what we need to get, our theta, but now let's figure out what would we need to get this. Well, if we could figure out this length, okay, and we could figure out the length B to O, let's call that B, then we'd be able to figure out what theta is, because this is a right angle triangle. So we would like to find OK and OB. Well, we actually know what O to K is. It's just 8 meters. Okay. But what is OB? Well, OB is the horizontal distance, OB, is the horizontal distance from K to B. So it's the horizontal distance that the shot goes through from K to B. It's the horizontal distance that the shot goes through. Okay, well, we know that it goes horizontally at 38 meters per second horizontally, but we don't know how many seconds it goes for. But for how many seconds? Okay, well, now this is now the amount of seconds is kind of what we're interested in now. Okay, well, how might we find that out? Well, we know that h is our height is our height above OB. And when we reach B, h is 0 at B. Well, now we can let h equal 0, and we have our formula for h, minus 6t squared plus 22t plus 8. So this will allow us to get how long the ball travels for, how long it takes for the ball to reach B. Okay, so if we solve this, if we use our quadratic formula, x equals minus b plus minus the square root of b squared minus 4ac all over 2a. Okay, and now let's just, well, what is a? A equals b equals c equals. Okay, so in this case, a equals minus 6, b equals 22, and c equals 8. So we get t equals minus 1/3, or t equals 4. Now, obviously, t can't be minus 1/3, so t must be 4. So it travels for 4 seconds. So how much distance does it cover horizontally in 4 seconds? Well, it's traveling 38 meters per second, and it travels for 4 seconds. So 38 by 4, which equals 152 meters horizontally. And we know that the distance it travels horizontally is just OB equals OB. So now we have OB. It equals 152, and this equals 8. And now this is going to allow us to find theta. So we know that tangent of theta will equal the opposite over the adjacent, and the side opposite to theta is length 8, and the side adjacent is 152. And now we can use our inverse tan inverse 8 over 152 to find theta equals shift tan 8 over 152 equals 3 degrees. And we have theta. It asks us in the question, find correct to the nearest degree. So theta equals 3 degrees. Now on to part D. At a later hole, Jones' first shot lands at the point G. Now on to part D. At a later hole, Jones' first shot lands at G. First shot lands at G on a ground that is sloping downwards, as shown. A vertical tree, CE, 25 meters high, stands between G and the hole. The distance GC from the ball to the bottom of the tree is also 25 meters. So GC is also 25 meters. The angle of elevation at G to the top of the tree, G to the top of the tree, E, is theta, and theta equals tan inverse a half. The height of the top of the tree above the horizontal, GD, is h meters, and GD equals d meters. So that's the distance to the tree. Write D and CD in terms of h. So write D and CD in terms of h. Well, let's first look at D. So for D. Well, we know that we have a right angle triangle, GDC, right angle triangle, GDC, and H, so we have an angle theta, and the opposite of theta is H, opposite H, and adjacent is D. We also know that theta, so theta equals tan inverse 1/2. Okay, so we know that tan theta equals H over D. Okay, so tan of tan inverse 1/2 is equal to H over D. And tan of tan inverse of something is just the something. So tan of tan inverse, they almost kind of cancel out, and we just get 1/2 equals H over D. And now we're trying to find D in terms of H, so we'll multiply both sides by D and then both sides by 2. So we get D over 2 equals H, and then we get D equals 2H. All right, now we're going to look at CD. We're going to look at CD. Well, we know that CD, so we know that CE equals CD plus DE. CD plus DE. Okay, and we know that DE is H. We know that this is H, and we know that this is 25 equals CD. And now we can solve for CD, and we get that CD equals 25, bring over the H, minus H. So we get D equals 2H, and CD equals 25 minus H. And finally, hence or otherwise, find H. Okay, well, how could we go about finding H in this diagram? Well, we could find this length, and then if we found this length CD, then we would be able to get H, because we have a formula including CD and H here. So if we got CD, we could solve for H. And how might we solve CD? Well, we know that CD equals 25 minus H. We know that CD equals 25 minus H, okay? And we know that D equals 2H. Well, if we try and put these together, then we get CD equals 25 minus D over 2. Okay, so now we have this length here is 25 minus D over 2. Okay, and if we notice, since EC is a straight line, this is a right angle. Because if this is a right angle here, and this is a straight line, then this also has to be a right angle. So we have a right angle here. We've got a right angle triangle with one length D. So we have a right angle triangle. So immediately Pythagoras, a squared plus b squared equals c squared. Actually, no. And now finally, we're going to take a look at part 2. So hence or otherwise, find h. All right, so let's just write down what we just got there, the formulas we just got. So we know that CD equals 25 minus h. And we also know that D equals 2h. Okay, so we're trying to find h. Now, if we were able to get CD, then because of this formula here, we would be able to get h pretty much straight away. Okay, so how might we get h? So we would like to figure out CD. We would like to figure out this length here. We notice that GDC is a right angle triangle. Okay, so the moment we see a right angle triangle, we immediately think of Pythagoras, a squared plus b squared equals c squared. Okay, so our A would be, so A is, let's say that's D. B is our other side that's not the hypotenuse, so that's CD. And C is our hypotenuse, which is 25. Okay, so we actually have a formula for CD, so we'll get a squared plus b squared equals c squared will become d squared plus CD, which is 25 minus h. 25 minus h squared will equal to 25 squared. Okay, so d squared plus 625 minus 50h plus h squared equals 625. All right, and now we can use our other formula here to get rid of the d. So we get 2h squared plus the 625's will cancel. So we get plus h squared minus 50h equals 0. Okay, so 2h squared, so this becomes 5h squared, 4h squared plus h squared, minus 50h equals 0. Okay, so we can cancel the 5 and cancel the h, so we get h minus 10 equals 0, and thus h equals 10.